Our topic for today is all about electric flux and Gauss law. Objectives: calculate the electric flux. Use Gauss law to infer electric field due to uniformly distributed charges on long wires, spheres, and large plates. Before we proceed to our discussion for today, let's recall our previous topic, which is the electric field lines. Electric field lines is the space around an electric charge. The direction of field lines in positive charge is outward, while the direction of field lines in negative charge is inward. Again, according to the law of charges, that like charges repel and unlike charges attract. And here's the general formula for the electric field by charged object. E is equal to F over Q. And E is equal to Coulomb constant multiplied by Q over R squared. Each charge is distributed in a surface area. Electric flux is the rate of flow of electric field through a given surface. It is also a scalar quantity. Let's use this simple diagram. We define the flux of electric field through the given surface area. Here's the general formula for electric flux. The symbol used to describe electric flux is the Greek letter P. Electric flux can be calculated in different orientation. Here's the first orientation. Calculate the flux of the electric field through the surface area in each of the three cases shown. In this orientation, surface area is perpendicular to the electric field. The angle between E and A is equal to 0 degree because they are both an x-axis. So, if we will be applying the equation of electric flux, it will be E times A times cos 0 degree is equal to 1. 1 is the maximum. Here's the second type of orientation. Comparing from our first diagram, our plate now is in this direction. Let's first determine the vector of electric field and area. The area is in upward direction while the field is in right side direction. Same equation and use 90 degree for the angle. It's 0 because there is no E passing through the surface. Next is the third type of orientation. The surface is slightly slanted. The direction of A is here and the direction of E is here. For example, the value of theta here is less than 90, which is 60 degree. Let's use the formula and here is the result. If the angle is greater than 90, it is negative. So if flux is negative, the E field is coming from the outside to inside. And if positive, the E field is from inside to outside. And here's the summary of the three different types of orientations. Next is what if the surface is curved or the field varies with position? Again, this is the general formula. First, get the differential area. Usually for often surfaces, like a hot coffee in a mug, particles are going outside. In case of a closed surface, like a can that you cannot see what's inside, it is symmetrical or same size. Use same equation in open surface and in closed surface but indicate the symbol for Gaussian surface. Gaussian surface means closed surface. Gauss law is an expression of the general relationship between the net electric flux through a closed surface and the charge enclosed by the surface. Here we will just get a part. If we're going to get this area, parallel A and E, and here's the result. Constant value for permittivity of space is here. And take note, this is for single charge. For multiple charges, here's the formula. You'll just add all the charges and divide it to the permittivity of free space. Carl Friedrich Gauss is the proponent of this law. And that's all for electric flux and Gauss law.